Let's take a moment to review the go-around in the light of some hazards that can occur and how these hazards can be addressed to make a go-around a safer maneuver. Special studies conducted showed that go-around procedures are not carried out in accordance with the SOP. This is especially true during high workload over a relatively short time. After the go-around is initiated, the flight crew must be fully committed in flying the published SOP procedure in the order given. Task allocation and sequence is clear in the standard operating procedures. Pilots must be prepared to shift rapidly from the approach procedure to a go-around maneuver. Having proper thrust and changing pitch to the go-around attitude should be intuitive as an instantaneous action. Go-around pitch for a given thrust will determine the longitudinal acceleration and vertical speed. Don't just make these changes, monitor them as well. Check that full amount of go-around thrust is applied and that the 8-degree pitch is initially flown, keeping at least VREF plus 20 knots in all engines or approach climb speed in all engine configuration. Manage these flight parameters through the whole maneuver. Applying thrust manually to the toga detent requires increased awareness. A detent error leaving the levers backwards leads to insufficient go-around thrust and will not set the go-around logic. Setting the levers beyond the toga thrust will develop go-around reserve thrust, which will give thrust in excess for most of the situations. Applying thrust manually also requires dedicated awareness to monitor or maintain airspeed. During a go-around, if the required pitch is not attained and maintained, the tremendous acceleration created by high thrust developed by both engines and low weight of the aircraft might create a situation known as somatographic illusion. Poor instrument scanning in low visibility go-arounds may cause the pilot to perceive the airplane pitching up when in fact it is pitching down. Pilots may try to counteract this misperception of climb by pitching down, which may end in a C-fit. After stabilizing in pitch and thrust, the performance and configuration of the aircraft must be ascertained. Speed, positive rate, gear up, and flaps. At all times, the pilot flying and pilot monitoring should be aware of the guidance modes that are armed or selected and of any mode changes. Significant changes to the FMS or guidance panel are performed by the pilot monitoring, which should be cross-checked by the other pilot. Normally, the pilot flying and pilot monitoring should scan flight instruments, moving his eyes to focus attention to the digital value itself, on time and in sequence. A good scan should include going back to the pitch indication each time your scan moves to a new indication, instrument, or control. No matter what else you check, always return to the attitude indicator between scanning other things. After the aircraft is stable in pitch and speed, scanning should include navigation, FMS, engine, flaps, trim position, etc. After the ATC asks for changes in the procedure, go back to the attitude indication and resume your scan. When the FMA engaged modes are different from the expected for the planned or required go-around, or when they are neither called out or checked, there is a great chance the aircraft will fly a wrong route or path. Any action on the autopilot flight director or FMS and its selected armed or selected modes should be confirmed by the FMA annunciation, called out and checked during the go-around. Beware that some scanning errors may occur. Fixation, for example, is more likely to occur, and any indication is not where it is supposed to be.
And its 2.0 here is incorrect as well.
So always cross-check interrelated data. Cross-check will detect changes, so that if you retract the flaps, the F-bug and green dot will change accordingly, allowing you to notice the change without looking at the flap lever or the flap position indicator. All changes should be cross-checked. Do not rely on just a single parameter to interpret your flight condition. When a pilot or both over-concentrate on a problem or on one instrument at the expense of general monitoring, poor control will result. Flying flight director commands, for example, may capture strong attention that can last long enough to compromise the monitoring of the basic flight parameters and take the airplane out of the intended flight path. Extreme nose-up attitude and stall, while going around, may result from a combination of speed excursion to very low speed where stabilizer trim has been compensated to a nose-up setting. When thrust is increased for the go-around maneuver, an upset may result, and the pilot may not be able to control pitch up with elevator only by correcting the aircraft attitude. Definitely, this is much more marked on all engines operating than on engine-out go-arounds practiced in flight simulators. The trim does not only provide control force relief, but it also provides increased control authority. The E-Jet's autopilot automatically trims out any pitch power couple. Any flap and landing gear change is also automatically compensated by the fly-by-wire system. However, when the autopilot is off, pitch trim automatic compensation is lost, so pilots must be aware that compensation will be necessary during the manual go-around.
Bank angle,
autopilot.
Whether it is a nose-up or nose-down upset, or even a high bank angle upset, troubleshooting the causes of the upset is secondary to initiating the recovery. The first action, once an upset is suspected, is to recognize and confirm the situation, then regain control of the airplane, and finally, recover from the upset using the upset recovery techniques. Communication with the ATC can take a lot of time and distract the crew from their priorities. Instructions from the ATC at bad times and the go-around, giving different instruction from those planned and briefed, can surprise and unsettle the crew, resulting in excessive workload, which is further aggravated by the speed the actions occur. The scanning and monitoring functions of the pilot monitoring will get compromised by ATC disruptions in sequence. Thus, the pilot flying will not follow properly the ATC constraints, as the pilot monitoring cannot update instruments as fast as things are going on. However, the monitoring function, mainly pitch, has priority over any other tasks. Learning and training how to prioritize effectively and not succumbing to distractions is an important skill. Aviate, navigate, communicate. Recall the 3 words that sum up the skill set of every aviator. At first, fly the airplane to stabilize in pitch attitude, bank angle, and vertical and horizontal flight paths. There is no value flight management at all if the pilot will not keep the aircraft clear of terrain. After aviating, navigating, and communicating, the next step is to manage aircraft systems and performance, following the applicable emergency or abnormal procedure.
Autopilot.
Landing gear.
By being go-around minded and instructed on how to recognize the need to go around, ensuring that the go-around is flown correctly. By knowing the difficulties that can occur and the appropriate procedures to cope with them can enhance a successful outcome on your go-around maneuver. Maintaining a good level of CRM throughout a go-around and addressing the respective workload with the priorities required by the flight situation are also good methods to maximize the performance of a procedure that is not frequently trained or executed.
Simply stated, the pilot flying should fly the aircraft, supervising the autopilot, vertical and lateral guidance, and auto-throttle operation, while manually flying